Simplifying complex numbers. In a previous video, we discussed how to simplify complex numbers with multiplication. In this video, we're going to actually take a look at how to simplify complex numbers that have division involved. So, as a preview, realize that we're going to have an idea of what this conjugate concept is. So if you have to revisit previous presentations, please do so at this time before moving forward. But as far as for this presentation, let's remember that in standard form, we're going to have a real component plus or minus an imaginary component. And our directions are going to be to write the following in standard form. So we're going to see problems that have, a complex number being divided by another complex number. So we'll scroll through the multiplication ones that we already completed. And then we're going to take a look at a couple new problems here. So with this first example here, I see that I have a real value divided by a complex number. And so this doesn't have just a real plus a complex. It actually has a fraction. So my first objective is to be able to get my denominator just to be a real number. So in doing so, what we're going to do is we're going to multiply by that concept that we refer to as the conjugate. So the conjugate in this case would be 3 minus I. Now, that 3 minus I is nice because what that's going to do for our denominator is that's going to make it 9 minus I squared, using that difference of squares concept. My numerator would now be 12 minus 4I. But now at first this doesn't look to be advantageous, but we have to remember again, I squared is actually equal to negative 1. So my denominator here actually becomes 10. 9 minus a negative would be adding one value, so that's where the 10 comes from. And then here we get 12 minus 4I. Now we're pretty close to what our actual answer is as far as a complex number in standard form, but we have to remember that it states that our complex number is a real value plus an imaginary value. So what we have to do here is I have to take this fraction and actually split it apart, such that I'll have 12 tenths minus 4I over 10. And I think from seeing that, we could actually see that we can go another step and actually simplify these because they have a factor of 2. So this would be 6/5 minus 2I over 5. There's our simplified complex standard form answer. Has a real and an imaginary. Now, the significant difference in our second example is you'll see that in our first example we just had a real value. Over here we actually have a complex number divided by a complex number. But again, our first step is going to be to multiply by the conjugate, which in this case would be 6 minus 4I. So, in doing so, our denominator is going to be 36, now be careful in this one, minus 16I squared. Students often forget to square the number that coincides with the imaginary value, so be careful of that. Make sure you have a 16 there, not a 4. Our numerator, well now we're going to go through that quote-unquote foiling or multiplying process. 2 times 6 is going to give me 12. 2 times negative 4I is negative 8I. This would give me negative 6I, and then this would be plus 4I squared. So at first it looks like we got a little bit of a mess going on, but we're going to attack each one, one at a time here. In my numerator, what I'm going to do is I have 12. This would give me minus 14I. And then don't forget the I squared is negative 1, so this is minus 4. So I did a little bit there, but all I did is combine my like terms and then rewrote the final term because I squared is equal to negative 1. In the denominator, this is going to become 36 plus 16, again, because I squared is negative 1. We're close to the end. What I have here is I got 12 minus 4 is going to give me a value of 8 minus 14I. And then 36 and 16 are going to give me a value of 52. But again, I'm not done yet. I'm going to go ahead and separate this. So that way I have 8 over 52 minus 14I over 52. So now with this, we have 4 over 26 minus 7I over 26. But we can go one step further, and we could actually go ahead and simplify this one to be 2 over 13 minus 7I over 26. So as you can see in this problem here, not only do we have a lot of, additional steps in the beginning portion, but when it comes down to the simplifying portion, make sure you simplify the final result completely.